Hello and welcome to Maths by SAS. This is my 17th lesson of D2, chapter number 2, exercise 2E, that is about solving simultaneous linear equations either by elimination method or substitution method. These lessons are equally important for D2 students and the students who are preparing the CIE examination. So, for the better understanding of the lesson, you have to watch all of the lessons in sequence because it's really important for the lessons of mathematics to integrate one lesson with another lesson. Let's move to question number 10, advanced level. Let's read the question from the book. Question says, using either elimination method or substitution method, solve the following pairs of simultaneous equations. In this lesson, I will solve question 10 A and B parts. Let's read the question, and it's really important to, before solving the question, we have to read and compare the question with the original question. The question 1A part is, one of the equation is 2 upon x over y equals to 1 over 2x plus y, and the second equation is 3x plus 4y equals to 9. Okay, if we look at the question, one of the equation is in form of the fraction. So first of all, we have to remove this fraction and we have to make the equation that is free from fraction. So first of all, we will be going for the cross multiplication. So equation will take the form 2 into 2x plus y equals to x plus y. Now apply distributive property carefully, that this 2 has to be multiplied with every term inside the bracket. It will take the form 4x plus 2y equals to x plus y. Now shift like terms on same side. 4x minus x plus 2y minus y equals to 0, or 3x plus y equal to 0. And this is the one of the equations that I'm getting, 3x plus y equal to 0. And now what we have to do, we have to write both the equations together, and equation 2 is 3x plus 4y equals to 9. If you look at equation 1, let it be equation 1 and this be equation 2. Okay, I can easily make y the subject of formula by shifting 3x to other side. Y minus 3, y equals to minus 3x. Now what I have to do, I have to replace y equals to minus 3x in equation 2. So we are going for the substitution method for this question. Replace y equals to minus 3x in equation 2 in second equation. Now equation 2 will take the form 3x plus 4 into y equals to 9, or 3x plus 4 into minus 3x equals to 9. 3x minus 12x equals to 9. 3 minus 12 is minus 9x equals to 9. Now shift this minus 9 to other side. X equals to 9 by minus 9, or x equals to minus 1. X equals to minus 1. Replace x equals to minus 1 in equation A. Let it be A. Replace x equals to minus 1 in y equals to minus 3x. So the value of the second variable will be minus 3 into minus 1. Minus multiplied by minus is positive, so y equals to 3. So the values of unknown for this question are x equals to minus 1 and y equals to 3. And let me block this answer for better understanding. Okay, and let me move to the next question, and let me read the question first from the book. Question says that 1 over 5 into x minus 2 equals to 1 over 4 into 1 minus y, and the second equation is 1 over 7 into x plus 2 whole 2 by 3 equals to 1 over 3 into 3 minus y. Now if we look at both the equations which are given in the question, they are in form of fraction. So first of all, we have to make these equations free from fraction. So let's take equation 1 first, and equation 1 is x minus 2 by 5 equals to 1 minus y by 4. Go for cross multiplication, that 4 will be multiplied by x minus 2 and 5 will be multiplied by 1 minus y. Now apply distributive property that this 4 has to be multiplied with every term inside the bracket, and same for 5. So the equation will take the form 4x minus 8 equals to 5 minus 5y. Now what we can do is that we can shift this 5y, 4x plus 5y equals to 5 plus 8, or 4x plus 5y equals to 13, and let's block this answer so that we can easily compare it when we are getting the other equation. Now let me take the second equation, and that is 1 over 7 into x plus, we can see that this number is the mixed number. I have to turn it in form of improper fraction. 3 to the 6 plus 2 is 8 by 3 equals to 1 over 3 into 3 minus y. Or what we can do is we can write it in the form 1 over 7 into, again take the LCM inside the bracket, that this is 3 into 3x plus 8 equals to 3 minus y by 3. Now go for cross multiplication, that 3 will be coming towards 3x plus 8, and 7 times 3 or 3 times 7 will be going towards 3 minus y. Now if we see carefully, both sides have 3 as the common factor. We can simplify this instead of making the big number. Now I will left with 3x plus 8 equals to 7 times 3 is 21 minus 7y. 7 3s are 21 minus 7y. Now turn this in form of the equations. 3x minus, when minus 7 will be shifted towards this side, this will become positive 7y. 21 minus 8, and 21 minus 8, 11 minus 8 is 3, 13, and the equation will take the form 3x plus 7y equals to 13. And now I have to block this equation. After this, I have to decide that which method I'm going to apply for the solution of this problem. If we look at the coefficients of x in both the equations, they're not same, and even the coefficients of y are not same. I will be preferring the elimination method for this question. So what we can do, first of all, I have to write both the equations together. 4x plus 5y equals to 13, and 3x plus 7y equals to 13. Now what I can do, I will be preferring the coefficients of x for the balancing. LCM of 3 and 4 is 12. So what I will be doing, I'll be multiplying equation 1 by 3, and I will be multiplying equation 2 by 4. So equation 1 will take the form 4 3s are 12x plus 5 3s are 15 y equals to 13 3s are 39. Coming to the second equation, 4 3s are 12x plus 7 times 4 is 28y, and 13 4s are is 52. Now after this, we have to observe the coefficients of x and y in both the equations. x has the same coefficient with same sign, so same coefficient, same sign, we have to subtract the equations and we have to change the sign of second equation. Okay, and when I'm changing the sign of second equations, we can see that we can get rid of 12 at this stage, and I will left with variable y only. And when I'm taking away 15 from 28, my answer will be minus 13y, because 28 is big, so 13 will have the negative sign. And same when I'm taking away 39 from 52, answer is 13. 12 minus 9 is 3 and 4 minus 1 is 1. Now in order to get value of y, what I have to do, I have to shift this 13 to other side. It will take the form minus 13 by 13, 13 ones and 13 ones. Value of y is 1. Okay, I'm getting the value of one of the variable. So what I have to do in order to get the value of other variable, replace y equals to 1 in equation A. It's always good to give some name in A. So equation will take the form 4x plus 5y equals to 13. Value of y is 1. 4x plus 5 into 1 equals to 13. 4x plus 5 equals to 13. Shift 5 to other side. 4x is equal to 13 minus 5. 4x is equal to 13 minus 5 is 8, and x equals to 8 upon 4. 8 upon 4. Read the table, 4 ones and 4 twos. X equals to 2. So the solution for this situation is x equals to 2 and y equals to 1. I hope you are clear about this lesson. For next difficulty level, please catch me in the next class. Watch my lessons, like, share and subscribe the channel and press bell icon to get the notification of every lesson in time. Thank you very much.